Ladies and gentlemen, thank you very much for giving me voice. I will talk about biogas and the availability of to produce polyhydroxybutyrate, which is similar to polylactic acid, and can polypropylene, similar to propylene condition properties, and polylactic and can be even like polyethylene low density. So this is important. We talk how to many times how to produce polyhydroxybutyrate and hydrogen, and is often used from algae. Here we have the potential to produce such a thing, such a polyhydroxyalkanoate from by biogas from the wastewater, and uh, this has been and the feed was wastewater and was it is based by article published in Biotechnology and Bioengineering by Professor Raul Munoz from Valladolid University. Okay, and is entitled Continuous Polyhydroxybutyrate Production on Biogas in an Innovative Two-Stage Bioreactor Configuration. And this is why made, because we need to produce electricity, heat, and other things important to use to produce other products of low bottom, and so all can be converted into energy and to green in raw materials for daily life. Here we have biogas production from using continuous stir tank reaction to two stage. First is continuous tank reactor, collect contact with and this bubble column bioreactor with internal gas recirculation. And the different approaches and the different nitrogen loading they were investigating. A balanced growth was obtained, and there was also nitrogen and multi-stage process, and the case is there were two groups, unusual group, as methanobacteria was taken methyl cystis hirsuta, which seems to be more available to polyhydroxybutyrate for production. So hydroxybutyrate than other bacteria due to some reaction, especially in case of microaeration 1 to 6 of atmosphere, and this is the case. The reaction, the bacteria was taken from Leibniz Institute and were first autoclaved in 120 liters air, and then after incubation for 17 days, and potassium, phosphorus, and iron salts nutrients were put in pH 6, 4, and 8 to the reactor of 25 liters, two stage, with equipped with pH, temperature, and volume control. The dilution rate was changes and inflow rate was coming. So every 5 minutes was aerated and sponged and gas mixture was produced recycle to produce already this polyhydroxy butyrate. So was the fast. The internal gas recycling was 1,245 milliliters per liter. Bioreactors are 9 days and were contain high loading rate, and this case his initial batch phase was in 3 days and then was continuous phase plant. The wastewater was taken from local plant, wastewater plant in case of oxygen flow rate, 10 to 1,000 chemical oxygen demand. These were measured uh, both how much nitrogen, how much is contained, and the was the changes resulting that in case of batch, how was influencing the change of potassium to, and this was giving, and the percentage of salic substrate, and in higher 25 uh, was of the high hydroxylation time was used, and in case of percentage, in case of changes of carbon of potassium nitrogen, the both stages, both batch and sparge, produce some amount of polyhydroxybutyrate, and high amount of polyhydroxybutyrate was considered in this 20 days time was coincide with lowest production of methane. So we have 15 and 10% in when my battery production in these cases reach only 30%. In other cases, when after this peak and lowering methane production, the lowering methane production and increase rapidly to 80% in case of higher retention time of 25 rotation 25 uh, gram per hour rate was better, and this is showing in case of no potassium and without addition the 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 polyhydroxybutyrate occur only in case of sparging. So we see how potassium is important that stimulate this polyhydroxybutyrate, And this is the case when we saw that. This is very important because we could need, and in case of supplying of nitrogen, recovering in case of 0.2 days per gram, and then or 0.3 days, we get in our case, and this resulted in much higher if we get nitrogen recycling than adding nitrogen by potassium nitrate. So this gives stable production of polyhydroxybutyrate from 40 to 20%, and we see that is not always, in most many cases, in 30 days, the higher is the higher hydrogen retention time. In this case, was uh, high retention, high fraction was independent on day different. So, and here we're not observing also some jump of methane production during peak of polyhydroxybutyrate. So this is that recycling of recovering of nitrogen addition from for recovering of the field from the feed is more important for production of polymers with no inhibition of methane production, which is the major task of bagasse plant. So these are a few hints how to produce methane and polyhydroxybutyrate. There wasn't any upgradation. So if we upgrade, for example, maybe with hydrogen production, the result could be very good. The methane production highest was 16 gram methane per hour, methane cubic meters, and polyhydroxybutyrate was highest of dilution rate 0 to 0.3 rate. The highest was 53 in this gram of polyhydroxybutyrate. So that's all for today. Thank you very much for listening.